In today's video, you will learn to solve equations involving indices. So first, I'll give you examples of exponential equations. They may be of type 2, like 3 raised to the power x is equals to 81. Or 2 raised to the power 4 is equals to 64. Right. So these are example 2 raised to power x is equals to 64. So these are examples of exponential equations. Exponential equations. Why they are called exponential equations? These are, the equation has an unknown exponent or index. So that's why they are called exponential equations. So these are simple examples of exponential equations. And the basic techniques to solve these types of equation is to make the basis same. So how can you make the basis same? You can express 81 as 3 raised to the power 4. And when you compare both sides, so you can write x is 4. So this is how you can solve an exponential equation. And you can solve this as well. You can write 2x is equals to 2 raised to the power 6. Because when you multiply 2 by itself 6 times, you get 64. And when you compare both sides, so you can write x is equal to 6. This is how you can find solution of simple exponential equations. Now I give you more examples. We solve question from exercise. Like question is of the type, for example, question number 1. It's 3 raised to the power 2x square is equals to 3 raised to the power 9x plus 5. Now you have to solve it. To solve it means that you have to find the unknown variable x. And this is an exponential equation. So you have to compare both sides. You see that bases are same on both sides. It's 3 raised to the power 2x square. And on the right hand side, it is 3 raised to the power 9x plus 5. As bases are already same, so you just compare them and you can write 2x square is equals to 9x plus 5. Now it's a quadratic equation. You take all variables on one side and you can factorize it. And factors are 10 and 1. So you can solve it by taking 2 as common. X minus 5 plus 1, x minus 5 is 0. And you can write x minus 5 into 2x plus 1 is 0. Then you can write either x is 5 or x is minus 1 by 2. So this is how you can solve exponential equations. So we do more examples. For example, question is 2 raised to the power n minus 1 is equals to 1 by 4. So remember, the basic concept is to make the bases same. So you can express this 4 in terms of 2 as well. So you can here write 2 raised to power n minus 1 is equals to 1 over 2 square. And you can take it up and we change exponent sign, 2 raised to power minus 2. And now you compare both sides because bases are same now. So here you can write n minus 1 is equals to minus 2 and can find the value of n minus 2 plus 1. So n is minus 1, right? Similarly, for example, you are given a question, an exponential equation, 5 raised to the power x squared minus 16 is 1. So again, remember that we have to I have to make bases same. Base on the left-hand side is 5, and on the right-hand side, we are given number 1. So how can you change 1 into 5? You know, according to laws of indices, you can write 1 as 5 raised to the power 0. Because if the index is 0, then that term is equals to 1. If the index of a term is 0, then the whole term is equals to 1. So you can write, instead of 1, you can write 5 raised to power 0. I am writing 5 here because the base on the left-hand side is 5. So you can write 5x squared minus 16 is this. Now bases are same. So you can write x squared minus 16 is 0. And then can make x as subject of the formula 16, and we take root on side, and when you take root, then you're supposed to put plus and minus sign, so x is plus minus 4. So this is how you can solve exponential equations. Now more questions. For example, question is 4 raised to the power. There may be a possibility when you are unable to make the bases on both sides same. First step may you see that you can take it up and write 8 raised to the power minus x plus 1 to avoid this fraction. First, we take this whole term up and you can write this. Now you see that in this case, bases are different, 4 and 8. But you cannot express 8 in terms of 4. Like you cannot write 8 as 4 square because 4 square is 16, not 8. So how can you need to change both bases here. Like you can express 4 as 2 square, right? And 8 as 2 cube because indices, bases on both sides must be same. And you can open this and can write minus x and minus 1. Now we apply laws of indices, multiply, be 10 minus 6x, and here it will be 2 raised to the power minus 3x and minus 3. Now you observe that bases are same and you can easily solve them. So you can write, cancel it, and you can write 10 minus 6x is equals to minus 3x minus 3. And we take all variables on one side. So it will be 10 plus 3 and it will be 6x minus 3x. So 13 is equals to 3x. So x is equals to 13 by 3, and you can write x is equals to 4 whole 1 by 3. So in this way, you can make bases same and then compare them, the exponents, and solve to find the values of x. Now we extend this concept. One more example. A question, for example, is uh, 2 to the power x plus 4 divided by 8 raised to the power minus x is equals to 64 over 4 raised to the power 1 by 2 x. So we apply same technique. You need to make basis same for applying laws of indices. So how can you express the smallest space you can change is into the rest of the terms is 2 here. So you can write 8 as 2 cube. And so when you multiply 3 by minus x, it becomes minus 3x. And you can express 64 as 2 raised to the power 6. And same is the case here. You can write 4 as 2 square. And when you multiply that square by 1 by 2 x. Right? Now you can see that bases are same on both sides. So there is a division sign. So we apply laws of indices and can write, change sign of this. It becomes plus 3x and this plus x becomes minus x. Now bases are same. So you can compare, you can write 4x plus 4 is equals to 6 minus x. And then can find value of x. Right, 4x plus x is equals to 6 minus 4. So 5x is equals to 2. And so x is equals to 2 by 5. So same way, instead of division, if you are given a multiplication sign between any two terms, then you can apply laws of indices and solve them. Like here you subtract, and in case of multiplication, you add indices. So basic rules are same to solve these exponential equations. Now I give you more examples. For example, question is next question is you are given a question of the type 2 raised to the power 3x into 1 over 8 1 minus y is equals to 32. So basic concept is same. We try to make all bases same first. So you can write 8 as 2 cube and 32 as 2 raised to the power 5. Now you take it up, it becomes minus 3, and you multiply this minus 3 by 1 minus y. Minus 3 plus 3y. There is the multiplication sign. So you add indices. So you will write here and 3x minus 3 plus 3y is equals to 5. Plus 3y equals to 5 plus 3, which is 8. There are two variables. So it means that there must be a second equation given to you as well. So yes, we have another equation as well. And basically these are called a pair of simultaneous equation given to you. Like this is equation 1. And there was another equation 125x divided by 5 raised to power y is 25. And you have to solve them simultaneously. So we repeat same process. You can write 5 cube. It will be 5 raised to the power 3x. And this is 5 raised to power y. And this is 5 square. Now bases are same. There is a division sign. So you can subtract. Right? Now you can compare. So 3x minus y is 2. Right? Now you are given two equations. We have two simultaneous equations. One of them is 3x plus 3y is 8. And second is now 3x minus y is 2. Right? So this is how you transform it. Now you can solve them simultaneously. You will write here 3x minus y is, second equation was 3x minus y is 2, right? So how can you solve it? Change signs. We are using elimination method. So it will be 4y is equals to 6 and y is equals to 6 by 4. Like y is equals to 3 by 2. You can simplify your answer as well, and you can give your answer in simplified form, which is y is equals to 3 by 2. And now you substitute this value and can find value of x, like we do in so you will write here like y is equals to, so I'm taking this first equation, 3x plus 3y is 8. Now you substitute value. This becomes 9 by 2. Now you take it on the other side. You take LCM. So 3x is 16 minus 9, which is 7 by 2. And now divided by 3. So x is 7 by 6. So this is how you can solve equations simultaneously. Now we do one more question. For example, question is of the type, for example, your question is solve the equation, solve 2y square minus 7y minus 4 is 0. And second part states that use your answer to part A to solve the equation. Equation 2 raised to the power 2x square minus 7 minus 4 is 0. So first, you can observe that when you compare these two, what you observe, that value of y is basically equals to 2 raised to the power x, right? They are exactly same. This is 2y squared minus 7y minus 4. And the second equation, which is in exponential form, is 2 into 2x whole square. It means the value of y is 2 raised to the power x, right? So first part may you need to apply simple factorization. We start A part. So factorize it. Factors are 8 and 1. You can write y minus 4 into 2y plus 1 is 0. So it means the values of y are 4 and y is minus 1 by 2, right? Now you have to use your answer. It is given that use your answer to part A. So it means the value of y is 4 and y in this case is basically 2 raised to the power x. So you can replace y by this term 2 raised to the power x. So here you can write 2 raised to the power x is equals to 4 and 2 raised to the power x is equals to minus 1 by 2, right? So you can write to express 2 raised to power x is equals to 2 square. And when you compare it, your answer is x equals to 2. And there is a negative sign over here. So that's why you cannot compare these two, right? So they are not equal basically. So you will neglect it. And your final answer is x is equals to 2, right? So in next video, we will do questions from past papers.